Okay, let's continue with question 2. You need to identify a molecule from the list to match this description, and you can only use each molecule once. So you may have a description that matches more than one molecule, but you're going to have to do elimination to get to the proper one. Different ways to do this kind of question. I'm just going to start with the left-hand side, and then I try to match, and I'm sure everyone has a different technique. Okay, so I have hydrogen sulfide. Now, if I just look at this very, very briefly, then you can see that it has some information about intermolecular forces, number of bonding pairs, double bond, shapes. And so I'm just going to go ahead and find out all of that about hydrogen sulfide. Hydrogen sulfide, it's going to look something like this. So you have a hydrogen here and you have a hydrogen here. Now sulfur is right below oxygen on the periodic table, so it does have the same number of lone pairs. And if I draw it in structural formula, considering the shape, then the shape of this is V shape, and it is definitely polar, with sulfur being the negative dipole and the hydrogens being positive dipoles. So the intermolecular force that it can have will be dipole-dipole. Okay, now let's see. So it's definitely not A. 6 non-bonding pair of electrons. That's not right. Only has 2 pairs, similar to a water molecule in shape. That sounds very promising. Doesn't have that or that or that. I mean, the only possible answer is actually C. So I know for sure that 1 matches with C. So I can cross that out. The next one, chloromethane. So you should be able at this stage to draw out what chloromethane looks like. So it has carbon with 3 hydrogen. All right, this is not ideal, but I guess it'll be okay. And the chlorine atoms does have 3 lone pairs of electrons. Okay, the shape will be tetrahedral because the carbon in the middle needs to arrange so that the 4 bonding pairs of electrons are as far apart from each other as possible, and it will have dipole-dipole just because of the chlorine. This molecule is polar. So dipole-dipole. Okay. So it's not A, contain double, no. So I think it's going to be E, tetrahedral with polar bonds. Okay. So next we have hydrogen fluoride, HF, 3 pairs of lone pairs. 3 lone pairs of electrons, and it has hydrogen bond. This is one of the 3 cases with hydrogen bond, being the strongest intermolecular forces present. Okay, I think it's going to be F. It is a linear molecule. Any molecule with 2 atoms must be linear. That doesn't mean that it's nonpolar. It's clearly not, but I don't think anything else will work. So I'm going to go with that. So 3 is F. 4, chlorine gas. Okay, so 1 chlorine, another chlorine, 1, 2, 3, 4, 5, 6. 4, 5, 6. So you do have 6 lone pairs of electrons or non-bonding pairs. So I think that's gonna go for B. Oxygen gas has a double bond here. Okay. Yeah, no, I think you can see it. 1, 2, 3, 4, 5, 6, 7, 8. Okay. So what can we have? Has dispersion forces. Now that could either be... Okay, actually I think A and D are correct for both of these, because if you think about CO2, it does have double covalent bonds. Or maybe the devil's in the S at the end. So for D, it does say double covalent bonds. Maybe that implies more than one. In that case, statement D will be applicable to number 6, and that will leave you with a phi being more applicable to A. Okay, that sounds good. That's it for 2.